Hello, this is the Explortle Careers in STEM series. Today we'll dive into the world of mathematics. Have you ever wondered how your GPS calculates the fastest route, or how Netflix knows exactly what show you'll binge next, or even how insurance companies know how much to charge you? Behind all these everyday technologies is one powerful tool: mathematics. Today we're exploring how math shapes our world and how you can turn a love for numbers into an amazing career. Mathematics is the study of numbers, shapes, patterns, and relationships using logic and reasoning. It's a universal language that helps us understand and describe the world around us. Math involves different topics like arithmetic, algebra, geometry, calculus, statistics and probability, and logic and set theory. So why is mathematics important? Mathematics is embedded in everyday life, whether it's cooking with precise measurements, shopping with percentages and discounts, or traveling using time and distance calculations. It also appears in nature through patterns like symmetry and fractals. Mathematics open the door to a wide range of fascinating and impactful careers. Whether you love solving puzzles, analyzing data, or making predictions, there's a math career for you. In this video, we'll explore 4 careers that all rely on mathematics in unique ways. First up, we have mathematicians and statisticians. What are they and what do they do? Mathematicians and statisticians analyze data and apply computational techniques to solve problems. Most work in government agencies, universities and research institutions, pharmaceutical, biotech companies, tech companies, and finance firms. Their work environment is mostly office-based or in academic settings. They have to work collaboratively, but often require independent work. Mathematicians and statisticians work with complex theories, proofs, and statistical models that require a deep understanding of topics like calculus, linear algebra, and probability. Next, we have actuaries. Actuaries use mathematics, statistics, and financial theory to analyze the economic costs of risk and uncertainty. Most work in insurance companies, pension and retirement planning firms, government regulatory agencies, and in consulting firms, and large corporations. Their work environment consists of an office setting. They often work in teams and consult with finance, legal, or risk departments. Actuaries rely on mathematics, particularly in the areas of risk assessment, probability, and financial mathematics, and they must pass rigorous exams that test advanced math skills. Next, we have data sciences. Data scientists use analytical tools and techniques to extract meaningful insights from data. Most work in tech companies, healthcare, finance, marketing firms, research labs, and government agencies. Their work environment is typically an office or remote/hybrid setup, often cross-functional, collaborating with engineers, product managers, and designers. Data scientists use statistics and linear algebra to analyze large data sets and build predictive models, though their work often blends math with programming and real-world problem solving. Next, we have operations research analysis. Operations research analysis use mathematics and logic to help solve complex issues. Most work in government, transportation companies, healthcare systems, and large corporations. Their work environment is typically office-based, sometimes with field visits depending on the industry. They will have to collaborate with other departments. Operations research analysis apply math to improve process and decision-making in business and logistics, requiring strong math skills but with a focus on practical applications and clear communications. Each of these careers play an important role in the STEM world, but 2 stand out as especially math-intensive: mathematicians/statisticians and data scientists. These roles not only require deep mathematical knowledge, but also the ability to apply it in cutting-edge fields like artificial intelligence, scientific research, and financial modeling. They're perfect examples of how math drives innovation and discovery across industries. The first career that we discussed that are STEM-heavy are mathematician and statistician. As previously mentioned, mathematicians and statisticians analyze data and apply computational techniques to solve problems. But what education does a mathematician and statistician need? They typically need at least a bachelor's degree or significant coursework in mathematics. In private industries, mathematicians typically need either a master's or a doctorate degree. Statisticians usually need a master's degree. Mathematicians and statisticians typically don't have specific certifications. Instead, they often have advanced degrees in mathematics or statistics, with some entry-level positions accepting bachelor's degrees. Many professionals also pursue certification from organizations like the American Statistical Association, ASA, or through programs like Villanova University's Graduate certificate programs. When at work, mathematicians and statisticians may work on teams with engineers, scientists, and other specialists. They usually work a typical 40 hours per week, but may work overtime and on weekends depending on their roles and responsibilities. How should you get ready to become a mathematician and statistician? In high school, students interested in studying to become a mathematician and statistician should take as many math courses as possible. High school students may want to adopt important qualities such as analytical skills, logical thinking skills, math skills, problem-solving skills, and communication skills. The median annual wage for mathematicians was $116,440 in May 2023. The median annual wage for statisticians was $104,110 in May 2023. Which career uses analytical tools and techniques to extract meaningful insights from data? That is a data science. So, as a data science, they typically need at least a bachelor's degree in mathematics, statistics, computer science, or a related field to enter the occupation. However, some employers require or prefer that candidates have a bachelor's or doctoral degree. While a specific single required certification doesn't exist for data scientists, many may still gain a certification to enhance their reputation. Popular and well-regarded certifications include those from IBM, SAS, Microsoft, and Cloudera. Data scientists spend much of their time in an office setting, most work full-time. So how should you get ready to become a data scientist? In high school, students interested in becoming data scientists should take classes in subjects such as linear algebra, calculus, and probability, and statistics. High school students may want to adopt important qualities such as analytical skills, logical thinking, math, problem-solving, communication, and computer skills. So how much will you get paid? The median minimum wage for data scientists was $108,020 in May 2023. Employment of data scientists is projected to grow 36% from 2023 to 2033, much faster than the average for all occupations. About 20,800 openings for data scientists are projected each year on average over the decade. Now let's test your math career knowledge with a quick quiz. Don't worry, it's a multiple choice, so it wouldn't be that hard. Think about what you've learned and see if you can pick the correct answer. So, the first question is, which career is most likely to involve building machine learning models and working with massive datasets? A, actuary, B, mathematician, C, data scientist, D, operations research analysis. The correct answer is C, data scientists. Data scientists specialize in analyzing large datasets using programming, statistics, and machine learning. They build models for tasks like recommendation systems, fraud detection, and predictive analytics. Question 2. Which profession uses probability and financial math to assess risk, especially insurance and retirement planning? A, statistician, B, actuary, C, data scientist, D, operations research analysis. The correct answer is B, actuary. Actuaries apply advanced math, especially probability and financial theory, to evaluate risk. They often work in insurance and pensions, helping organizations prepare for uncertain events. Question 3. Who is most likely to develop mathematical theories with no immediate application which may become useful in the future? A, operations research analysis, B, actuary, C, mathematicians, D, data scientists. The correct answer is C, mathematician. Mathematicians, especially those in theoretical roles, often explore abstract concepts that don't have direct applications, though history shows many of these ideas eventually lead to major breakthroughs in science and technology. Now let's move on to the last part of our video, fun facts. Mathematics may seem like a serious subject, but these careers are full of surprising and even quirky facts. So I'm going to select 2 facts that I found interesting. Let's head to actuaries. Actuaries are constantly ranked among the top careers for job satisfaction, work-life balance, and salary. And becoming an actuary takes passing up to 10 exams, but fortunately, many companies support employees by paying their study time and materials. Moving down to operations research analysis, their models helped FedEx and UPS optimize delivery routes, saving millions of dollars and cutting down emissions. Well, that's it for today's video. Thank you for joining us today. Don't forget to follow us on Instagram at Explortle or through email to stay updated on our STEM series. See you next time.